Now, to conclude this course section, there's one special widget I want to show you. A widget you don't have to use, but a widget that can help with loading data through HTTP requests or with working with futures in general. And keep in mind that, of course, when sending an HTTP request like here with GET, we are getting such a future as a result. And that widget would be the FutureBuilder widget, a widget which listens to a future and automatically updates the UI as the future resolves, so as the future produces some data. Now, this FutureBuilder widget could be used here in the grocery list Dart file in our build method, and they're actually inside of our scaffold in this place here where we have the content. Here, instead of outputting the content, we could use the FutureBuilder widget. Now, the FutureBuilder widget needs at least two key parameters. It needs a future, so the future to which it should listen in the end, and a builder which wants a function that will be executed whenever the future produces data. And therefore, that is a function that receives a context, automatically passed in by Flutter, and a snapshot, which in the end gives you access to the current state of the future and the data that might have been produced. Both arguments are passed in by Flutter because Flutter will call this function based on the state of your future, and therefore now here we also need a future. And here for this future in this scaffold widget in my grocery list Dart file, I in the end want to have a future that produces that list of grocery items once we got a response from this GET HTTP request. Now, to get such a future that produces that data, we could change the load items function. Instead of returning void here, we could say that this function should return a list of grocery items. Now here we'll then actually get an error because since we're using async here, this will automatically return a future, as you see here. This async keyword basically ensures that the function that's decorated with it will always produce a future, automatically. Dart will take care about that. Therefore, the correct type annotation for this function here, for this method, is that we'll get back a future which will eventually resolve to a list of grocery items, which can be expressed with this generic type. So now load items should be a method that returns a future, which it will do automatically because of async, as you learned, which will then in turn resolve to a list of grocery items. To make sure that that's the case, we have to go to the place here at the end where we set our state and get rid of this set state action here and instead return our loaded items. So we return that list of items. I will also get rid of this catch block and of this curly brace that belongs to the try block, because I will get rid of this overall try catch block, because with FutureBuilder, as you will see, we can handle errors in a different way, in a way that requires less code from our side, which can be quite convenient. Now here in this case here, where we got no response, I also don't want to return nothing. Instead here, I simply want to return an empty list. Because we got no response, hence we got no items, therefore I want to return an empty list. Because keep in mind, load items should now return a list in the end. A list of grocery items. Now we also don't need to set the loading state manually anymore. Thanks to FutureBuilder, we'll soon do that in a different way. And here where I'm setting this error state, I'll comment this out because we'll also soon handle this in a different way. So that with all those changes made, we got a leaner load items function which still sends this HTTP request and transforms all that data, but which then in the end returns that transformed data. Now down there in the build method at the very end here, it's now therefore my load items function, or to be precise, the result of calling that function that will give me the future that should be assigned here. But this code here is actually not correct. Technically it would work, but it's discouraged to write this code, and it's considered a bad practice to write this code. Because if you call load items here to get that future that will be passed as a value to FutureBuilder, this function will be re-executed every time the build method executes again. So every time some state changes, for example. And we don't want that. We don't want to re-execute this all the time. Instead, this function here should only be executed once when this widget, this grocery list widget here, is loaded for the first time. For example, because the app started up. That's the only time where this should be executed, because that's the only time where we want to fetch all those items from the backend. Therefore, instead of calling load items here, you should instead add the initState method, which you can add here, or which we already did add here to be precise, to actually create your load items future there. Now for that, I'll actually get rid of this isLoading variable, because we won't need it anymore, and instead I'll add a new variable, which will be of type future, which then eventually resolves to a list of grocery items, and I'll name it loaded items. And initially, I have no value here, but I will store a value here in initState. There I'll set loaded items equal to calling load items. Load items then will produce that future, and that's therefore exactly what I store in loaded items. Now here I'm getting an error because I got no initial value here, and this is a non-nullable value. And to work around that, we can use a special keyword, the late keyword, which we can add in front of this type. This is a keyword built into Dart, which in the end tells Dart that we have no initial value for loaded items, but we will have a value before it's being used the first time. And indeed, this is the case here because we do assign a value here in initState, which will be executed before the build method executes in the end and before this future is needed. So with late, we basically tell Dart that everything will be okay. So then we have the loaded items property, which holds a future, and it's now that property that we can use down there as a value for future on that FutureBuilder. And this will now only be set once when initState runs, but it's then this future to which Flutter will listen and for which it will execute this builder method as this future changes its state from being initialized and pending to being resolved or rejected in case an error occurred. And now speaking of these different states, now that we got this future in this builder method, we should return a widget. And typically we don't just want to return one widget here, but different widgets based on the current state of the future. And for that we got this snapshot here. We can then add a if check here in this builder function, for example, and take a look at this snapshot and then use this snapshot to evaluate the current state of that future. And for that we can use the connection state property on this snapshot object, which can have a couple of possible values. For this we can use the connection state enum that's built into Flutter, and here we got the different values connection state could have. For example, it could have waiting, and that will be the initial state when we send the request and we're still waiting for the response. So that's our loading state in the end. And if we are waiting for a result, we might want to return our loading spinner. So I'll grab that code here, where I render this center widget with the circular progress indicator, and I'll cut it and get rid of this if statement here. And instead down here, I want to return this if our current connection state is waiting. Now, if we're not waiting, that means that we have a result. But the result could now either be that we have data or that we have an error. So therefore here, we want to add another if check, and we can use this snapshot object again to check whether we might have an error with this built-in hasError property. This will be true if our future has been rejected, which simply means that an error has been thrown inside of the code that produces the future. So in load items, if we throw an exception, the future will be rejected. For example, if get throws an exception because of a missing internet connection, the future will be rejected. And here, where we're manually checking for an error status code, and we previously set the error property to a message, we can now throw an exception ourselves. And that's a great example for a scenario where you do want to throw your own exception. Here, we're doing it to make sure that this future, which is produced by async automatically, will be rejected, and therefore down here in our builder, has error will be true. That's why we, for example, here want to throw an exception. Now we can pass our own error message here to this exception, like failed to fetch grocery items. Please try again later. And with that, the future will be rejected. And now down there in our builder method, in this if check, where we're checking for the existence of an error, I now want to return a different widget if we make it in there. And that widget will be this center widget, which we used for displaying an error in the past as well. And we can get rid of this if check here, therefore. And it's now this center widget which I want to output here, but I'm not referring to this error property now. But instead here, I now want to use snapshot. And then there, I got this error property, which gives me access to this exception object in the end. And here, I can call toString, and that should normally output the error message. Now, of course, we also want to handle the case that we're not waiting and that we don't have an error. So put in other words, that we have data. And for that, here, I want to output my list or this fallback text if I have an empty list. So therefore, I want to add yet another if check here in this builder method, where I can check if snapshot data, which is the data we will have in the end, if that is not empty. Or if we want to show the fallback here, if it is empty. So if we have an empty list here. Now data will be such a list of grocery items or null, though here we know that it won't be null because we don't have an error and we're not waiting for the future to resolve. So at this point we should have data. And therefore here I add this exclamation mark to make it clear that here in this app this won't be null. But if it's empty, if it's an empty list, then I of course want to return this fallback text. So I'll grab this center widget with this fallback text, get rid of that variable here, and now show this here. And if we also make it past this if check, we know that data is not empty, that it is a list of grocery items. So now we can grab this list view here, cut that, get rid of this if check up here in the build method. And now down here at the very end of this builder method, and then here we add our list view builder, so this list view widget. And there we're now outputting all these underscore grocery items. However, here we should not use this property because here we're inside of this builder function that belongs to FutureBuilder. And as mentioned before, this builder function in the end exposes the state and the data produced by that future through this snapshot object. Now this loaded items future in the end of course is the future produced by load items, and that future either produces an error if we throw an exception or if any other code in there throws an exception. In that case, as mentioned, the future will be rejected. And that would lead to this has error property on snapshot yielding true and this widget being returned. But if it's not producing an error, load items will produce a list. It will resolve to a list, the loaded items list or an empty list. And that list is available through that snapshot object as well. So in here, in that builder function that belongs to the FutureBuilder, inside of this function here, we want to use this snapshot to get hold of the loaded data. Through snapshot.data, And then here an exclamation mark to tell Dart that this will not be null, which we know because if we reach this point, we will have some data in this app here. So in all the places where we use grocery items, we want to use snapshot data with that exclamation mark at the end here instead. With that, we should be outputting the loaded data. And if you now save everything and reload this app, you should see any data you have on the backend here being loaded. So we have the loading spinner initially, briefly, and then the data. But you will also see that for this app, we also got some problems. If I, for example, add a new item like milk here, you will see that it's not showing up here. Only if I restart the app, it is being loaded. So it was sent to the backend, but somehow the UI was not updated correctly. If I delete an item, we get an error, so that's also not good. And the reason for all these problems is that now we're loading and displaying our list data through FutureBuilder. But in the end, this builder function here only executes once when this future is created and executed for the first time, so to say. Once the future is done, so once it resolved with data, this builder method here will never execute again, even if you call setState and the build method executes again. That will recreate the future builder, but not the future, since that future is created in its state and therefore only once. And therefore the builder method of FutureBuilder also doesn't execute again. That's why this UI never updates and why this list, for example, never updates. That's why for this app here, where we're loading data that's then actually manipulated from inside the same widget, FutureBuilder might not be ideal. Now you could restructure the code and write it in different ways to still make add item and remove item work as before, but for this app it actually might be preferable to simply not use FutureBuilder. Nonetheless, I of course wanted to introduce this widget because it is an important widget. You will also see it later in the course in a place where it's more useful, and you might also see it in other projects. In addition, you can of course hopefully see that this is a very elegant way of handling these different states a future might have and of outputting different content on the screen, even if in this app it's not ideal because of the complexity of this screen. But if you had a screen or a widget where you only need to load data, show different states based on whether you're done loading or not, and you have no other logic related to the data, FutureBuilder might be ideal. So for this app here, I would actually go back to the state we had before, and I just wanted to introduce you to this widget, but in other projects, FutureBuilder could be very useful because it can simplify this process of rendering different UI states based on the current state of a future.